This is Chapter 6, Lesson 2, Equations of Linear Relationships. How can you express a linear relationship between two quantities in different ways? 1, we can graph linear relationships using tables, and 2, we can graph real-world data. A linear equation is an equation whose graph is a line. Linear for line, the graph is a line. Okay, so it's really easy once you have the formula. You have the equation. You can figure out a lot of things. And I think in today's homework, they're going to give you all of the equations. Eventually, you're going to have to come up with the equations yourself. So let's just say that they want us to graph this equation. So you always draw your table like this on your homework. Show all of your work. Sorry, it didn't print off very well. Okay, this is your x, this is your y. And then we're going to put them together here at the end, so you'll have your coordinates. So we're just going to use some random numbers, because all we want to do is graph a line. So if x is -1, let's write our formula. 2 and x is -1 plus 1. And what does this equal for y? 2 times the -1 is -2 plus 1 would be a -1. So my points would be -1, -1. So I would come down here and I could graph -1, -1. So let's find another one. Let's say 0. 2 times 0 plus 1. 0 plus 1 is 1. So this order pair would be 0, 1. 0, 1. Okay, remember, they gave me the equation. So if you're wondering where I'm pulling out these numbers at, all I am is simply putting an x here. You're putting x in for the equation and you're solving it. And you come up with your new ordered pairs. If we choose 1, that would be 2 times 1 plus 1, which would give us 3. So 1 and 3. 1, 1, 2, 3. And then if I chose 2, I would do 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5. So my x is 2 and my y is 5. So 1, 2, 1, 2, 3, 4, 5. This is your x, this is your y. Remember, you always find your x and then your y. Always find your x and then up or down for your y. Okay? It's that easy. Now let's look at your homework. I went ahead and made all the tables because you're going to have to make them too and show all your work. We did do number 1 in class, so I'm going to skip it. Let's start with number 2. So you should make a table like this on your notebook paper, and they gave you the formula. So make your table, and we're just plugging numbers in. 1, 2, 3, 4. And there's your formula. So we have -2 times x. Well, x is 1 plus 6. And I'm going to let you finish it out. I'm just going to help you plug in the formulas. So here we have -2 times 2 plus 6. If I plug in 3, -2 times 3 plus 6. So remember, I'm using the formula that they gave me. So 4. So you solve it, and then you need to plot it on your graph that they've supplied for you on number 2. Number 3. Benjamin is saving money for a new laptop computer. He already has $50 in his account that his grandmother gave him for his birthday. Now he plans on saving $25 per week. The equation is y equals 25 times x plus 50. Represents the total amount of money Benjamin will have saved after X numbers of weeks of savings. So he wants to know, he already has the $50 and he's going to save $25 per week, plus 50. So let's see how many weeks it's going to take for him to get how much money. So again, you're going to make your table. Your x's, your formula that they gave you right there, 25x plus 50. Then when we find this out, we're going to find your y, and then you're going to put them into the ordered pairs, and you're going to graph them. So let's start with 1. 25 times 1 plus 50. 25 times 2 plus 50. 25 times 3 plus 50. 25 times 4 plus 50. Okay, so once you get all your y's and then your ordered pairs, you're going to come over here and graph it. Okay, so A is your graph, but you have to do the table to get to the graph. And then B asks, how much money will Benjamin have saved after 10 weeks? So that's why I put 10 down here, because that's your answer for B. So it's 25 times 10 plus 50. And you really only need this money amount here. You don't have to graph that one. That's your answer for B. Okay? Number 4. Peyton needs to have his truck repaired. The parts he needs to have replaced cost $145. The labor charged by the mechanics is $110 per hour. Here is your equation. Y equals 110x plus 145. Represents the total cost of Peyton's truck repairs for X number of hours worked on by the mechanic. Represent this linear equation on the graph. So let's make our table, and then we can graph it. So I took my formula that they gave me and put it here. We're going to create your x's, you'll find your y's, and then you'll have your ordered pairs. Then you're going to graph it. So 110 times 1 plus 145. 110 times 2 plus 145. 110 times 3 plus 145. 110 times 4 plus 145. Find your y's, find your ordered pairs, and graph them. And always know these are your x's and this is your y. X, y, just in case you forget. Always label your graph. And B, how much will the repair cost Peyton if it takes the mechanic 4 hours to complete? So after you've graphed your line, you want to take this amount right here, and this is your answer to B. But it must be in money form. Okay? How much money will it cost for 4 hours? So this is your answer in money for answer B. Okay, on the back. Went ahead and, like I said, I made our tables because you need to make them on notebook paper yourself. So number 1, the pizzeria charges $6 for a medium cheese pizza plus $1.25 for each additional topping. The equation y equals 1.25 times x plus 6 describes the total cost y for x toppings. Complete the table of ordered pairs showing the relationship between the total cost y and the number of x toppings. Okay, so you have your chart. We have $1.25 times 1 plus 6. $1.25 times 2 toppings plus 6. 3 toppings would be $1.25 times 3 plus 6. $1.25 times 4 plus 6. So remember, $6 is for the pizza. The $1.25 is for extra toppings. So for 4 toppings, just fill in your y's and then your ordered pairs and fill in the blanks. Okay, but show your table. Okay, number 2. A recreation center charges $35 per month for a membership fee plus an initial $70 registration fee. The equation, here's your equation. This describes the total cost y for x months. Complete the table of ordered pairs showing the relationship between the total cost y and the number of months x. So again, we're just going to plug it in. They gave us the formula. So for 35 times 1 plus 70, 35 times 2 plus 70, 35 times 3 plus 70, 35 times 4 plus 70. Okay? And then fill in the blanks. Number 3. A heating and air conditioning repairman billed a customer for $170 for his service. The repairman charges a flat rate of $60 for the service plus $55 per hour for labor. The equation, I gave you the equation, describes a total charge y for x hours of labor. Graph the equation and determine how many hours the repairman worked at this job. So here is your equation I wrote. They gave it to us, transferred it to your table, draw your table out, and we're just substituting 1 in, or x into the formula. So 55 times 1 plus 60. 55 times 2 plus 60. 55 times 3 plus 60. 55 times 4 plus 60. 55 times 5 plus 60. Now then, we're looking for a magic number. Okay? That magic number is $170. So when you get to $170, you have found your answer. Okay, because that's what they want to know. How many hours did he bill them? Because the bill was $170. So when you get to $170, your answer is going to be how many hours. Okay? You may not have to go all the way down. I just put it here because that's what I was used to doing. But you're looking for the magic amount. And when you find that magic amount, stop and put how many hours it took. Make sure you label it hours. Number 4 on the back. Ralph is saving money. He already has $50 to make more money. He mows lawns in his neighborhood for $40 per lawn. Graph the equation to find out how many lawns he will have to mow in order to save $250. So we're looking for $250. But your answer is how many lawns. So your answer is going to be blank lawns. Okay, you must label it. Okay, they gave us the formula. Actually, I guess they didn't give you the formula, so I'm going to give you the formula. Okay, so Ralph is saving money. He already has $50. That's why we just added 50, because he has $50 in his account. He mows lawns and he wants $40 per lawn. So $40 per lawn plus the 50 that he has. And let's see how many lawns he has to mow to get the magic number of 250. So 40 times 1 plus 50. 40 times 2 plus 50. 40 times 3 plus 50. 40 times 4 plus 50. 40 times 5 plus 50. Remember, you're looking for this number. So and you're going to have to graph it too. Okay, so use your ordered pairs, put it on the graph. You're going to put number 3 on the graph too, just in case I didn't say that. Graph them both, and then look for that magic number, and then how many lawns. Okay? And number 5 says, using the table from exercise 1, determine the number of additional toppings if the total charge is $12.25. So, if we go back to your table in exercise 1, okay, if you have this filled out, you're going to figure you're going to have to add another one there. Show your work. So 125 times 5 plus 6. Okay? And your answer is going to be toppings. And this one's going to be hours. This one, oops, sorry. This one is lawns. And this one's going to be months. But you must show all of your work on notebook paper. Okay, number 6. Using the table from exercise 2, determine the number of months if the total charge is 280. So we'll refer back to our chart, number 2. And the magic number we're going to look for now is 280. You're going to have to add on, okay? So keep looking until you hit that magic number. When you reach 280, that's how many months it's going to take. So add on to your number 2 table. And if you need to transfer it onto another piece of notebook paper, since I ran out a little bit here, you can do that. Okay? We have a workshop tomorrow. I'm not sure that we'll be in too early for help, but you can always come and see if anyone's here.